So what happens when we can't take an antiderivative for functions like this, where doing a u substitution doesn't help us? Well, we've looked at Riemann sums using rectangles, and today we're going to look at how to use trapezoids to also calculate the area under the curve. So go ahead and pause the video long enough to get all of this drawn in and labeled, so that then we can start working with it. And notice that as I connect the two bases on this trapezoid, it's almost like I'm actually drawing along the curve. So unlike the Riemann sum, I don't get the too much or too little. And of course, if I increase the number of trapezoids and therefore make the distance between the bases smaller, remember this, all of these are my delta x, then that curve, as I would connect these, would get even smoother. So remember the area formula for your trapezoid is 1/2 base 1 plus base 2 times height. We're going to use that repeatedly. And nothing's changed in terms of solving for delta x. I take the width of the interval, which is b minus a, and divide by however many trapezoids, in this case n. So now, if I number these trapezoids, I'm going to find the area of each of these, and then I would add them all up to get the total area. So if I start with trapezoid 1, I have to do 1/2. Now, the two bases, of course, are running vertically, so it's f of x sub 0, because I want the y heights, I want the heights, the y values, so f of x sub 0 plus f of x sub 1 times delta x, which is my height. And if I want trapezoid 2, I'll do 1/2, but this time it'll be the y value for x1 and the y value for x sub 2, which are my bases. And trapezoid 3 will be the y value for x sub 2 and the y value for x sub 3. And then going all the way out to trapezoid 8, I would have the height for x sub 7 and the height for x sub 8. And so what I notice is that several of these vertical heights show up for 2 of the trapezoids. And that will keep going, and the only ones that won't show up twice will be the first one and the last one. So I could simplify this to this formula where I've factored out the 1/2 delta x from every term, and then I've combined all of the y values on the inside. So notice I have 2 of f of x sub 1 and 2 of f of x sub 2 and so forth, but I only have 1 for f of x sub 0 and 1 for the last x value, whatever it happens to be.